Welcome to The Explainer. Today, we're diving into one of the most fascinating and, frankly, concerning threats to artificial intelligence, adversarial attacks. Now, this isn't about traditional hacking. We're talking about something much more subtle. It's about manipulating the very way an AI thinks. So let's just start with a question that should probably be on the mind of any leader who's deploying AI. What happens when your systems aren't just wrong, but they are absolutely confident that they're right? You know, the easiest way to think about this is like an optical illusion, but for a machine. To you and me, these images are clearly pandas. But with a tiny, practically invisible change, what researchers call adversarial noise, the AI sees the image on the right not as a panda, but as a gibbon. And get this, it's 99% sure about it. That right there is the danger we're talking about. So, why does this need to be at the top of your risk register? Well, it's because this vulnerability is literally hiding in plain sight. It targets the fundamental way your models have learned to see the world. And this isn't some academic theory. Researchers have actually done this. They put a few small, strategically placed stickers on a stop sign, and it was enough to make an autonomous vehicle's AI classify it as a speed limit 45 sign. The AI isn't confused. It's certain, and it's dead wrong. And this is really the key takeaway for anyone in a leadership position. Traditional cyber attacks, they go after bugs in the code. Your team can find those and patch them. But adversarial attacks, they target the AI's learning process itself. There is no simple patch for that. This forces us to completely rethink our entire security strategy. Okay, so to build that new defense, we first have to really get our heads around how these attacks work. They go right to the heart of how AI learns from data in the first place. So, how do they pull this off? It's not random guesswork. Attackers are basically reverse engineering the AI's learning. They use sophisticated math not to teach the model, but to find the absolute smallest change they need to make to an input to push it just over the line from a correct classification to a wrong one.
Now here's what's really, really concerning for security leaders, this idea called transferability. It means an attacker doesn't even need access to your fancy proprietary model. They can build an attack against a publicly available one, and there's a shockingly high chance it'll work on your system too. So that whole idea of security through obscurity, it just completely falls apart here.
Now let's broaden the view a little, because this is definitely not just a problem for self-driving cars or image recognition. This threat stretches across pretty much every domain where you might be using AI. The attack surface is just huge. We're talking about everything from using specially designed glasses to fool facial recognition, to writing phishing emails with specific text that your AI spam filters just won't catch, to hiding audio commands in background noise to hijack your smart speakers, and even tweaking the numbers in tabular data to fool a loan fraud detection model. So why are our existing security tools so bad at catching this? Well, it boils down to something called the semantic gap. See, our tools are great at checking if an input's format is correct. It's syntax. But the attack isn't in the format. It's in the meaning, the semantics, as the AI understands it. And this table just lays it out perfectly. Your input validation tools, they'll pass the attack because it's a perfectly valid file. Authentication? Well, a legitimate authenticated user can be the one to submit the malicious input. Encryption? Sure, it protects data on the move, but the attack is baked into the data itself. We really need a whole new playbook for this. So what does this new playbook actually look like? Well, it's not about searching for a single silver bullet solution. The answer, as it so often is in security, is all about defense in depth. A truly robust strategy has 4 key layers. The first is adversarial training. You're basically vaccinating your model by showing it these tricky attack examples during its training. The second layer is input preprocessing. Think of this as sanitizing the data before the AI ever sees it, trying to smooth out any of those malicious tweaks. Third, you've got adversarial detection. These are specialized monitors that are trained to look for the statistical fingerprints of an attack. And finally, number 4, is using ensemble methods. Basically, instead of relying on one AI, you get a second opinion from several different models. You know, it's much harder to fool a whole committee than it is to fool a single person. Okay, so for the final piece, let's talk strategy. What are the key decisions you, as a leader, need to be thinking about to actually put this defense into practice? This is a big one. You have to understand and be comfortable with the accuracy versus robustness trade-off. See, making a model tougher against attacks can sometimes mean it becomes slightly less accurate on normal everyday data. This isn't a technical flaw. It's a strategic, risk-based decision you have to make depending on what that system is actually doing. So, your investment plan needs to be proportional to that risk. You should focus right now on your most critical systems. We're talking authentication, fraud detection, anything safety-related. Then, next quarter, look at the systems that carry reputational risk, like content moderation. And then finally, you can address those lower priority internal tools. The good news is, you don't have to start from zero. To help guide your technical teams, there are some fantastic frameworks out there, like MITRE Atlas and the NIST AI Risk Management Framework. They provide the structure you need, and then open source tools like IBM's Adversarial Robustness toolbox can help with the practical implementation. So, the key takeaway, the question I want you to bring back to your team is this. In an adversarial world, just being accurate is no longer good enough. The real question is, are your AI systems truly robust?